Non-uniform bending apparatus consists of a beam, whose Young's modulus have to be determined, which is placed on two knife edges with slotted weights hanging at the middle of the beam. The distance between the knife edges is kept as 60 centimeters. A dead weight W is hanged at the middle of the beam. A traveling microscope is used to view a pin fixed vertically at the midpoint of the beam and measure the height of the beam. When viewed through the traveling microscope, the pin appears upside down. The tip of the pin is made to coincide with the horizontal line of the crosswire using the vertical fine adjustment screw, and the height of the beam is measured. The readings are taken on the vertical scale of the traveling microscope. The vertical scale consists of the main scale and the vernier scale. The main scale reading is the reading on the main scale where the zero of the vernier scale is pointing. The vernier scale coincidence is the division on the vernier scale which is making an exact straight line with any of the main scale divisions. In the present illustration, the main scale reading for the dead weight W is 5.10 and the vernier scale coincidence is 40. A slotted weight of 50 grams is gently added to the weight hanger, and this makes the beam bend downwards and the pin moves downward as the height decreases. As we are seeing an inverted image, it appears to us as if the pin moves upwards. Using the vertical fine adjustment screw, the tip of the pin is again made to coincide with the horizontal line of the crosswire. The readings are taken on the main scale, and the vernier scale coincidence is also noted. The readings are recorded in the tabular column. The load is increased in steps of 50 grams, and readings are noted for each load by the same way. The readings are noted while loading and also while unloading the slotted weights. The total reading TR is calculated using the formula shown above the tabular column. This is the height of the tip of the pin for various values of load at the middle of the beam. The reading for W plus to 50 grams while unloading is the same reading as the reading while loading. All other readings may vary slightly. The least count of the traveling microscope is 0.001 centimeter. The average value of the two sets of total readings are calculated. In the calculations, the values are rounded to 3 decimal places. The depression of the beam is calculated for every 150 grams by finding the difference between the average readings corresponding to W and W plus 150. Similarly, we can find the depression for another 150 grams by finding the difference between the reading corresponding to W plus 50 and W plus 200 grams. We get 3 sets of such readings whose average is taken as Y. The thickness of the beam D is measured using a screw gauge at various places on the beam. The breadth of the beam B is measured using vernier calipers at various places on the beam. In the present example, the average thickness of the beam is 5.54 mm and the average breadth of the beam is found to be 2.54 cm. Substituting these values in SI units along with the average depression, Y, for 150 grams in the formula, the Young's modulus of the wooden beam is calculated.